All right, guys, welcome back to our notes. So this is topic 2. Go ahead and write topic 2 at the top of your notes. So we have topic 2. All right, cool. So today what we are doing is we are solving systems of linear equations with substitution and elimination. I'm going to explain both of these methods right now, but before I go into it, I want to show you something we've done before. Bam, this was in Unit 1, and I actually printed this out so everyone has this. Now I'm showing you this so because it's going to help you with what we're doing today. Remember, we have 3 types of solutions. We have one solution, we have no solution, or we have infinite solutions. Okay, infinite solutions. Now I want to refresh your mind. Remember, when we have these 2 equations, right, when we're solving for this, and I do my math and I have a letter equal a number, that's when we have one solution. A letter equals a number, right? And it's only one answer. Okay, now when do we have no solution? Remember when we're solving these equations here, and when I have 2 numbers that are different on both sides, that's when we have no solution. This is a refresher. We've already done this before, right? 9 does not equal 0. That's a false statement. So this is no solution. Okay, when do we have infinite solutions? Remember when we're solving this and I get the same equation on both sides, or I get the same answer on both sides, then that is a true statement, which means we have infinite solutions. Now that's what we're doing today. But we're doing it by a different method. This method is called substitution. Let's start with that. So here are the instructions. So step 1 says solve one equation for x or y. Then we need to plug that expression into the other equation. And then we're going to plug that answer back into the original equation. So let me kind of do a basic example before we jump into these little more complex questions. So let's look at this real quick. I have substitution basic. Here are my 2 equations. So here's one equation and here's a second equation. Now, substitution, we take one of these equations here, we take one of these, and we plug them into the other one. Now here's how. Notice this equation right here says y equals 5, which means I can take this y and take it out and put a 5 there instead of y, because the top equation says y equals 5. So I can rewrite this as this. X plus 2. I'm going to put a 5 here now because y is equal to 5 plus 3. Okay, all I did was substitute. I substituted that top equation into the bottom one. Now I'm going to solve this. When I solve this, what do I have? Let's see. We have x plus 10, right? Because 2 times 5 is 10, equals 3. And I'm solving for x, so I want to get x by itself. Here is my x. How do I get that by itself? I need to, right, subtract 10 here, subtract 10 here. So now I have x equals, what is that, a negative 7. Okay, now my solution, the point that we have is going to be x comma y, right? So it's x comma y. So my x value is negative 7. My y value is 5. That is my solution right there. So let's go. That's just a basic example. Let's go to these real quick. So step 1 says solve one equation for x or y. Basically, I need to get one variable by itself. And I try to choose the easier ones. I think this one right here is going to be the easiest, because look, if I get rid of this 2x and move it to this side, I already have y by itself, and that's what I want to do. So that's my first step. I'm going to do that. So let's take this equation right here. If I do minus 2x here, minus 2x here, what am I left with? I have y equals negative 2x plus 9. Negative 2x plus 9. Okay, so now I have my 2 equations, right? This is one equation that was left the same. Here's my new equation that I put into slope-intercept form. Now what I want you to see is that I'm going to plug this here into where y is, right? Because if y equals negative 2x plus 9, then I can change this y right here. I can change that y, and I can substitute all of this in. So this is how we do it. So now I'm going to do, I'll write it down here. So we have 2x minus 3. Now parentheses, anytime we substitute something in, we always get to parentheses, minus 2x plus 9, close my parentheses, equals negative 11. All right, now we need to solve this. Notice we only have one variable, right? We have x here and we have x here. When I solve this, I'm just gonna try to x by itself, and then I can know what is x equal to. What is the x value? So here's my first step. We need to get rid of these parentheses right here, and we have to do that by distributing. So this -3 needs to be distributed into this parentheses. So if I want to distribute that, what do I get? So -3 times a -2x is a positive 6x. -3 times a positive 9 is a -27. And bring down what you have not used yet, -11 here. I'm going to bring down this 2x. Okay, cool. Now, my whole goal is to combine like terms, right? Here's a like term, here's a like term, and then these are like terms, and these are like terms. But I want my x's to be on one side and all my constants to be on the other side, the numbers that don't have x's or any letter next to them. So let me go ahead and combine like terms. So I know that 2x plus 6x is 8x. All right, and I know in order for me to cancel out this -27, I have to do inverse operation. So I'm gonna do plus 27 here, plus 27 here. So what do I have left on this side? 27 minus 11, that's going to be 16, right? That's gonna be 16, and then let me write this right here, 8x, because that's what this is supposed to be. All right, last step, I need to solve for x, so I'm going to divide by 8. Divide by 8, x is equal to 2. All right, now x equals to 2. Now what we do with this is, I know the solution. I know my solution is, it's gonna look like, so my solution's x value is 2. I gotta figure out what is this y value. So now I take this point, or I take this x value, and I plug it back into one of these. All right, it doesn't matter which one you plug it into. I usually try to find the one that already has y equal to. So I'm gonna plug it into this one down here. So I have y equals -2x plus 9. Now I know what my x value is, right? My x value is equal to 2. So I'm gonna rewrite this, -2 times 2 plus 9. All right, that's what y equals, so I need to solve it. So y is equal to -2 times 2 is a -4 plus 9. Y is equal to a positive 5. So I'm going to take that y value, put it right here. So I have my solution. This is my solution right here. It's one solution. Right, all done. That's how we do substitution. So we'll do one more example real quick. Actually, I would encourage you guys to pause the video. You try it yourself, and then play the video to check your work. All right, so here we go. Step 1, make sure that we solve one equation for x or y. So let's go up here. Which one of these do I want to solve for x or y? It doesn't really matter. I'm going to solve this one for y because look, y is already by itself. Okay, so for me to solve this for y, I need to subtract 3x. Okay, and then subtract 3x on this side. What do I have left? I have y equals -3x plus 2. All right, now how does that help me? Here, I'll just scratch this out because that's what gave me this equation down here. Now here are my two equations, right? Here's one equation, here's one equation. This is where, look, if we know y equals -3x plus 2, well, let's just substitute this part into where y is, and then we can solve for x, or we can solve for, yeah, we can solve for that. So I'm gonna write it over here, 6x plus 2y, but y is equal to what? -3x plus 2, parentheses equals 4, right? This part right here goes right there. All right, what's next? We need to basically solve for x, combine like terms, so I need to distribute. Let's go ahead and distribute. So it's a positive 2 times a -3x, and a positive 2 times 2. All right, so what do I have? So positive 2 times -3x is a -6x. Positive 2 times 2 is a positive 4. Bring down what I have not used yet. And we just got to combine like terms. Right, this is a like term, this is a like term. Here's a like term, here's a like term. I want to get all my x's to one side and all my constants to the other side. So 6x minus 6x, well, that actually just cancels out, right? That just goes to 0. That's 0. So then what do I have left? I have 4 equals 4. Well, 4 equals 4 is a true statement. Remember when we go back to here? Infinite solutions. When I have a true statement just like this, where I have the same number on both sides, that's infinite solutions. So that's what this answer is right here. So this is infinite solutions. Infinite solutions. And that's how we do substitution. All right, I'm going to make another video for elimination.